So picture this. You're hiking the rugged, windswept cliffs of Cape Lookout in Oregon. It's a crisp autumn afternoon. You're walking through a really vibrant, amazing smelling temperate rainforest, right? And you reach out to grab this freezing cold metal railing so you can look down at the crashing waves of the Pacific Ocean. Now, in that exact split second, your eyes, your nose, your skin, they are completely absorbing raw, chaotic physical forces from the environment. But that's really just the baseline. What's absolutely mind-blowing is how your brain seamlessly takes those tiny electrical pulses and weaves them into a full-blown emotional reality filled with swimming sea lions down below. Welcome to This Explainer. Today, we're diving deep into the incredible divide between what we physically sense and what we actually perceive.
All right, let's look at our roadmap for today's explainer. 1. Sensation versus perception. 2. The limits of sensation. 3. Anatomy of the senses. 4. Multimodal perception in action. And finally, 5. Real-world sensory hazards. Let's just jump right in.
Section 1. Sensation versus perception.
So the easiest way to think about this is to think of sensation as literally your biological hardware. It's the absolute physical baseline, where your sensory organs are out there actively catching raw inputs from the world, stuff like light waves or sound frequencies. And through this lightning-fast process called transduction, your body actually converts that physical energy straight into electrical signals for the brain. Perception, though, well, that is your psychological software. That's the process of selecting, organizing, and interpreting all those neural inputs. See, while sensation is pretty much uniform across healthy people, perception is what determines how you uniquely experience the world. It's heavily colored by your own memories and emotions. Basically, sensation collects the raw data, and perception builds your subjective reality.
And this ancient biological setup is constantly colliding with modern technology. We're actually seeing this right now with next-gen virtual reality headsets causing severe sensory mismatches, especially for college students who are stuck in these headsets remotely for hours. They're getting hit with intense, very real physical vertigo. And why is that? Well, it's because their visual fields are registering super fast motion from these immersive screens, but their inner ears, which remember dictate your balance, they're detecting absolute stillness in the dorm room. It's a perfect example of a technological glitch violently disrupting that super delicate boundary between raw physical sensation and our mental interpretation of it.
I really love how the philosopher Henri Bergson summed this up. He said, "The eye sees only what the mind is prepared to comprehend." It's such a powerful reminder, right? Our psychological perception ultimately calls the shots, and it dictates our subjective reality, sometimes completely overriding the raw physical data.
Okay, moving on to Section 2, the limits of sensation. Now, understanding exactly where our perception even starts is absolutely crucial. Imagine you're sitting inside a completely silent, windowless research lab. You're straining to catch the exact precise moment a faint whistle pierces the quiet. That high-stakes test, that maps your unique, absolute threshold. It basically finds the exact line where physical sound waves finally trigger enough receptors to cross over into a conscious psychological event detected at least 50% of the time.
But, it's not just about detecting something out of total nothingness. It's also about noticing changes. Enter the differential threshold, or what's sometimes called the just noticeable difference. This is the minimal physical change required for you to realize that two stimuli aren't identical anymore. And this ties directly into sensory adaptation. When we're bombarded by constant, unchanging stimulation, our receptors actually slow down their firing rates. And hey, this is totally a feature, not a bug. Our brains are actively deleting boring, steady background details so we can actually survive and focus purely on vital, changing modifications in our environment.
Let's put this into a real-world context. Think about college students living in those incredibly crowded, noisy communal dorms. They adapt super rapidly to all that background noise, completely thanks to sensory adaptation. But if you're pulling an all-nighter, studying in a completely dark room, your differential threshold for light becomes incredibly sensitive. I mean, we all know how annoying it is when a roommate's laptop brightness subtly shifts and just completely ruins your study groove. These everyday environments heavily interact with our basic sensory limits. So I want you to just think about this for a second. Look around wherever you are right now. Does background noise affect your focus at home? Or have you completely adapted to the hum of your AC or the traffic outside, only to be jolted by a tiny, unexpected change? All right, let's hit Section 3, Anatomy of the Senses.
Each of our senses has a highly specialized biological function. Take vision, for example. Ambient light waves enter the eye, they strike the photoreceptors on the retina, and boom, They are instantly converted into electrical energy. The optic nerve then blasts those signals straight to the primary visual cortex. And the truly cool part here isn't just the biological wiring. It's the crazy fact that in literally a fraction of a second, raw, meaningless light waves are magically transformed into our rich, complex psychological experience of color, depth, and spatial orientation.
But what happens when the hardware works fine, but the projection software is totally broken? Well, look at the incredibly bizarre and tragic clinical case of visual agnosia. Researchers observed this patient whose eyes worked flawlessly. She captured light perfectly, but she literally could not identify a simple set of house keys placed right in front of her. Actually, scratch that. It wasn't her eyes. It was a structural breakdown along her neural pathways that prevented her brain from assembling those anatomical pieces into a recognizable object. The raw physical sensation was totally intact, but the perception was completely, inexplicably gone.
And we see a really similar, incredible journey with our hearing, or audition. Mechanical sound waves travel through the air, they funnel into the ear, and they vibrate these tiny, tiny little bones that stimulate fluid-filled structures inside the cochlea. Just think about how wild that is for a second. A few tiny vibrating bones and some fluid are literally converting invisible air pressure changes into electrical thoughts that you comprehend as language or music. It's wild.
But because those auditory hair cells inside the cochlea are so incredibly fragile, we really have to be careful. Medical journals have been reporting this pretty alarming trend lately. College students using cheap, uncertified wireless earbuds are suffering localized, permanent damage to these cells. They're experiencing early signs of tinnitus, that constant ringing in the ears, and routine clinical brain scans are even showing altered neural projections because of it. It's a massive, real-world warning that our everyday audio habits can permanently alter the super delicate anatomy of our nervous system.
Moving on to Section 4, multimodal perception in action.
So our brains rarely ever work with just one sense in isolation. Multimodal perception is how we process information from multiple sensory modalities as a single unified experience. To show you just how powerful this is, let's look at the famous rubber hand experiment. A researcher hides a student's real hand from view and places a lifelike rubber hand right next to it. Then, taking a soft paintbrush, the researcher simultaneously strokes both the hidden real hand and the visible fake hand. The visual sight of the fake hand being touched fuses with the tactile sensation on the hidden fingers. And suddenly, bam, the student jumps in surprise when the researcher hits the rubber hand because her mind completely adopted the artificial limb as a true part of her body. Sight and touch combine to literally trick the brain.
And we see this cross-modal cooperation all the time with our food, too. Just imagine a family Thanksgiving gathering featuring a blindfolded taste test. You give your relatives different popular brands of sweet cola, but deprived of their sight and all those familiar visual branding cues, their taste buds suddenly just completely short-circuit. They struggle to differentiate between these super competitive beverages that they drink all the time. It completely proves how deeply interconnected our senses are. Stripping away visual cues totally changes how we actually experience flavor.
This dynamic is captured so wonderfully by Maurice Merleau-Ponty. He said the senses mix like colors on a palette to paint our ultimate perception of reality. And we're actually using this principle as a major life hack today. Educational researchers have found that interactive, multimodal online textbooks, the ones that combine auditory lectures with synchronized visual text, they significantly improve retention rates. Engaging multiple senses simultaneously creates a way stronger learning experience, which honestly is an amazing tip for anyone balancing a busy schedule who needs to reduce mental fatigue while trying to absorb new information.
Finally, Section 5, Real-World Sensory Hazards. Understanding our sensory limitations isn't just some abstract academic exercise. It is practical, life-or-death safety. Take dark adaptation, for example. That's how our eyes increase sensitivity in low light. Imagine a driver traveling down a dark, rainy highway late at night. For just a split second, he glances down at a glowing smartphone screen. His eyes instantly adapt to that intense, bright digital interface. But when he looks back up at the road, his eyes require a significant recovery period to readjust to the pitch black. That temporary loss of dark adaptation prevents him from seeing a stalled vehicle just ahead. It's a harrowing scenario for sure, but it perfectly shows that ignoring how our biology works can result in immediate, absolute disaster.
Another really major hazard is inattentional blindness. This is a critical failure of awareness, where we completely fail to perceive obvious surrounding events simply because our intense focus is deployed somewhere else. A recent campus safety report revealed this massive increase in pedestrian accidents when students text while walking across busy university intersections. These students are frequently experiencing inattentional blindness. They fail to perceive oncoming vehicles despite having completely clear, unobstructed lines of sight. It's terrifying.
The absolute crucial point here is this. Raw visual sensation means absolutely nothing if our limited attentional resources are deployed elsewhere. As Anais Nin profoundly stated, we do not see things as they are, we see them as we are. Our expectations, our focus, and our strict biological limits act as heavy, heavy filters, aggressively shaping the reality we believe we're moving through.
So as we wrap up this explainer, I want to leave you with a bit of a provocative thought. Think back on your own highly constructed perception of reality. Have you ever missed something completely obvious simply because you were distracted? It really makes you wonder just how much of the real world we are actually missing every single day. Thanks so much for joining me to explore the amazing world of sensation and perception. Keep your eyes and your mind wide open.